Welcome to Pod4 Journal Club. Today, we're digging into some really cool new research that tackles one of the biggest problems in AI today, trust. I mean, how can we be sure an AI isn't just getting lucky, but that it actually understands the logic behind its answers?
All right, here's how we're going to break it down. First, we'll talk about the core problem, getting the right answer for the wrong reason. Then we'll introduce a really clever new solution called PRoSFI. After that, we'll look at the data to see if it actually works, be honest about its current limitations, and then wrap up with what this all means for the future of AI.
So, let's set the stage here. We all know large language models, LLMs, are getting incredibly good at some really complex reasoning, but there's a huge catch. It turns out that when we train them just to get the final answer right, we can actually, without meaning to, encourage sloppy thinking. And that brings us to the absolute heart of the matter. What good is a correct answer if the logic behind it is just nonsense? For AI to be truly useful in high-stakes fields, like medicine or engineering, we have to be able to look under the hood and verify its work.
Think of it this way. It's like a math student who scribbles a bunch of random stuff on the page but somehow miraculously guesses the final number. You can't be sure they've actually learned anything, right? And you definitely wouldn't trust them with a harder problem. This is a major hurdle for creating reliable AI, because if they can get things right by accident, our trust in them just completely falls apart.
So to solve this, the researchers came up with a brand new training method, and this one is designed to reward the entire reasoning process, not just the final guess. Let's see how this new approach tries to build a much more trustworthy model.
Okay, it's called PRoSFI. It's a bit of a mouthful, I know. It stands for Process Reward over Structured Formal Intermediaries. But the core idea is actually really simple. Instead of just checking the final answer, PRoSFI forces the AI to show its work, to break down its logic into these structured, machine-checkable steps that a computer can rigorously check for any errors.
And this slide shows the difference perfectly. Look at the top path. That's the old way. You get the right answer, you get a reward. Simple. But now, look at the bottom path for PRoSFI. Even though the AI got the correct answer, which was false, one of its reasoning steps failed verification. You see that little red X? Because of that one mistake in its logic, it gets a low reward. It's actually being punished for sloppy thinking, even with the right answer.
So here's how that process actually works. First, the AI just thinks in natural language, like it normally would, but then, and this is the key part, it translates its own logic into a structured format. A formal prover, which is basically a logic checking program, then goes through and verifies every single step. Only if the entire chain of reasoning is perfectly valid does the AI get the big reward.
So the theory sounds great, right? But does it actually work in practice? Well, the researchers put PRoSFI head-to-head with the old outcome-based method on a really difficult set of logical reasoning problems to find out. Now, before we see the results, it's super important to understand how they measured success. Because getting the right answer is one thing, but they needed a way to measure if the process itself was correct.
And that's where this new metric comes in. They called it soundness. And it measures the percentage of time the model gets the right answer and uses a logically valid, verifiable reasoning path to get there. It's not enough to be right. You have to be right for the right reasons. That's the real test. And here are the results. And wow, it is pretty dramatic. Now, both methods got the final answer right at a pretty similar high rate. But look at the soundness. The standard method was logically sound only about 22% of the time. PRoSFI just blows it out of the water, skyrocketing that number to over 76%. That is a huge leap in reliability.
Okay, so this shows a massive improvement on one specific test, but real learning, true intelligence, means you can apply your skills to new problems you've never seen before. So the researchers decided to test exactly that. They tested it on those classic knights and knaves logic puzzles. The ones where some people always lie and others always tell the truth. And check this out. As the problems got harder, the soundness of the standard model just fell apart. It drops all the way down to below 48%. But look at the PRoSFI model. It stays incredibly high and consistent, staying above 80% even on the absolute hardest puzzles. That's really impressive.
Now, of course, no single study is a magic bullet, and the authors are really upfront about the current limitations of this approach. It's a fantastic first step for sure, but there's still a lot of work to do.
The bottom line is, while this is a huge step forward for formal logic puzzles, applying this to the
Well, the messiness of general language or other really complex topics is going to take more work. They'll need bigger, more diverse datasets, even stronger base AI models, and maybe even more nuanced reward systems that aren't just a simple pass or fail.
So let's wrap all this up by talking about the real-world impact and what this kind of research unlocks for the future of AI.
This right here is the big takeaway. This method gives us a path towards building AI systems that we can actually trust for really high-stakes applications. Imagine a medical AI that doesn't just give you a diagnosis, but also gives you a step-by-step, completely verifiable logical path for how it got to that conclusion. That's the kind of game-changing reliability this research is aiming for.
And that leaves us with a really fascinating final thought. Formal logic is one thing. It has clear rules, you can verify the steps. But the next great frontier is going to be teaching AI to reason reliably about the subtle, unwritten, and often messy rules of our world. You know, common sense. How in the world do we teach it that? That is the big question this research helps set the stage for.